Vector addition is very simple. Pictorially, here's our coordinate axes again. I'm going to have two vectors. I'll call this vector u, and I'll call this vector v. And although it seems like, oh, it's important where they start, no, all I'm doing is that u could just as easily translate, let's make it a little more accurate. U could just be down here starting at a different point, but it's still the same vector. 2u, if I multiply that, you're going to see that I'm just going to increase the length by double. That would be 2u. But if we're going to add vectors, I need to know what their I and j, or their coordinate values are. Well, this u, it looks like I have it equal to maybe 3, 2. Goes over 3 and up 2. This goes backwards 2 and up 4. So I write this as a minus 2, comma 4. This goes to the left 2 and up 4. So adding u plus v then is equal to 3, 2 plus minus 2, 4. And if you think about it, I'm just going to take this v vector and slide it over so that the tail of the v is at the head of the u, and it's going to go like that. And so this point here is going to be, when I am going to sum it up, it's going to be 3 plus a negative 2. And this point, my y coordinate or my j vector portion is going to be 2 plus 4. So my u plus v then is going to be 1 and 6. And kind of the way I drew it is, well, I'd have to start at the origin, but at any rate, it's not a great graph, but you can certainly find vector graphing apps that you can play with this. Nevertheless, to add vectors, all we're going to do is add the x components and the y components. It really is very much like adding two coordinate points in the coordinate plane. What's different is this has direction, this has direction. So let's suppose that my vector was 3, 5, and I wanted to triple the magnitude of that. I would just multiply and get 9, 15. So my vector would go from looking like this to looking like 3 times as long. So we can multiply vectors through by what's called a scalar, by a constant. We can do that. Let's see, what else can I show you about vectors? Vector subtraction. U minus v. Let's suppose that u is equal to 1, 5, and v is equal to 3 minus 2. Then u minus v, I already have it up here, is going to be 1 minus 3, which is be negative 2, and 5 minus a negative 2, which is 7. Again, you're just taking the components and doing this. Don't think that you can multiply vectors like this. Multiplication is one of those operations where the vectors, the group of items that we call vectors, gets very funny. So we're going to cross that. Pardon the pun, you'll see why. We'll take care of that in a future video.